So before I start this, I just want to invite everybody to an event that I'm going to be hosting October 8th at 5:30 p.m. Pacific time. We're having a bunch of experts in a variety of fields talking about how to confront legacies of health disparities. So Caleb Cage, the COVID-19 coordinator for Nevada, Francoise Bayless, a bioethicist at Dalhousie University in Canada, who's a research chair and has been involved in a lot of major issues in bioethics. This is an issue I really care about, and so I think it's going to be really interesting. I'm excited about it. So we'll talk more about that in class. Okay, let's transition from space to climate. Sorry, there we go, transitioning. So we're going to start off with a big discussion of space, and here we're specifically going to focus on international agreements with respect to outer space and how we thought about what outer space was. Sputnik is launched October 4th of 1957, of course, and almost immediately after, people all around the world started contemplating what this meant for what new era we were in. Joshua Lederberg started writing to several of his colleagues and eventually published an article coining the term exobiology in 1960 in the journal Science. Here he cautioned against what he called forward and backward contamination. The idea of forward contamination is humans could take creatures unknowingly to other bodies, like the moon perhaps, or Mars. And that could be bad for a variety of reasons. One reason is scientific. If we contaminated these celestial bodies, we wouldn't know whether or not life had existed there independently of us before us. We wouldn't know whether or not it had just been us contaminating it. It might also perhaps cause some ethical issues, some moral issues, in that if we contaminated other bodies, they might destroy the habitat, and perhaps we want to protect that in some way. Backward contamination is a little bit more straightforward about why we should care about it. Namely, what if there are microbes out in space? It's not obvious that we would do well with facing something completely new, right? It might turn out that some of them might eat our food or make us sick or something, and it could turn out really poorly. So don't bring anything back either. Just be very, very careful about what we're doing. So he starts worrying about this, and it causes other people to start worrying about it as well. And eventually people start contemplating whether there should be some sort of international agreement, especially seeing as between that period, between Sputnik and the signing of the Outer Space Treaty, there had been nearly a dozen impactors, landers for each country on the moon and on Venus. So it seemed like there needed to be some rules of the road. And in 1967, the United States, the Soviet Union, and the United Kingdom, countries that presumably were dominant in space, although the United Kingdom didn't have much of a space agency, that they should come to some agreement. They called it the Outer Space Treaty. One of the precursors to the Outer Space Treaty was something called the COSPAR, which I put the Committee on Space Research. It still meets. They adopted a resolution a couple of years before, arguing about forward and backward contamination, right? So the search for extraterrestrial life on is an important objective, and contamination would make such a search more difficult. All practical steps should be taken to ensure that Mars not be biologically contaminated, and sterilizing techniques are required to avoid contamination. So scientists were on the ball, trying to get governments to be on the ball as well. And in 1967, nations from around the world signed this outer space treaty with certain provisions, right? Outer space should be free for exploration and use by all states. Objects are not subject to national appropriation or claim of sovereignty. No nuclear weapons or weapons of mass destruction in space. Celestial bodies should be used for peaceful purposes. States are responsible for the national space activities of their citizens. We talked about this in class. States shall be liable for damage caused by their space objects, and they shall avoid harmful contamination of space and celestial bodies, so forward and backward contamination. Avoid the harmful contamination that also has adverse changes in the environment of the Earth. So this is becoming concerned with the idea of environmental damage. I mean, it doesn't seem shocking to you guys, and it probably wasn't even that shocking then. But when you look historically, the very first environmentalists were not that long before this, right? There were advocates of cars early on that said, "Oh, it's cleaner than a horse because there's no poop; it just goes off into the air," not thinking that toxins and smog could accumulate in the air, right? We blocked out all of the light from all of the stars in all of our cities before we started realizing that this stuff was hanging around. Even national parks were relatively new, right? So in the 1920s, there had been this concerted push by Harding, Coolidge, and Hoover, these counter progressive Republicans who were president, and they were hoping to nationalize the national parks, which Teddy Roosevelt, who was a progressive Republican, had pushed for. So environmentalism was not really on the minds of a lot of people for much of human history. In fact, when you look at human society, historically, we don't seem to realize that, like the reason Europe doesn't have forests is because of actions of individual humans, right? And they didn't seem to realize that they were chopping down things that weren't going to grow back as fully. Even our political philosophies, John Locke talks about how nature is bountiful and we can just take and take and take from it. It only gains value when we add work to it. So, okay, Outer Space Treaty is recognizing some environmental issues. All right. That's one bit of background, one bit of setup for why space and climate have a relationship to each other. After this, we're going to talk about something called the overview effect, and some images, and then the early environmental movement before we talk about the hole in the ozone layer and the role that NASA had to play in that. So again, I mean, I know this seems like we're doing a pretty hard pivot from space to climate, but there are several connections. These are three very distinct but important connections. All right, what is planetary protection? Planetary protection is essentially environmentalism for the planet. We only have one planetary protection officer who protects all of the planets all of the time. And so when we think about planetary protection and the role that this officer has, there's a couple of different justifications that we could imagine having with respect to the environment. This is, if you were taking an environmental ethics class, this is what we would spend a couple of days on, right? The distinction between preservation and conservation. So preservation is that nature is worthwhile in and of itself. Conservation is that nature is worthwhile because humans need nature. I've asked this question in many classes that I've taught, and it seems like a lot of students believe in conservation. They don't necessarily believe in preservation, but I get quite a few preservation students anyway. The point is that there might be something that is valuable independent of humans in the preservation ethic, but not so much in the conservation ethic. So you might think that life itself is worth protecting, intelligence, sentience, etc. On the other hand, you might think that it's only because future generations need to have access to this. This is what Teddy Roosevelt pushed for when he was proposing national parks a century ago. And this can manifest in a couple of ways: health, science, future generations. All of these are in contrast to the idea of exploitation, that nature exists for us to exploit, that nature is not so fragile that we can harm it for future generations. It is there for us to take advantage of. Even here, if you do subscribe to this ethic, there's still some equity and economic concerns to think about. So even if nature is meant to be exploited, there's still other ways to think about it, other issues to think about. So roughly speaking, the environmental approaches that we could take break down into these three. Okay. So keep that in mind as we move forward. And I talk about this thing that I've mentioned a couple of times, that Apollo 12, which launched in December of 1969 after Apollo 11 finally landed on the moon, one of the missions of Apollo 12 is to try to bring back a Surveyor 3 camera, which had been launched 2 years before. The idea was that humans walking over to a previous launch site, previous landing site, would be able to bring something back in person. It was going to be, I don't know, just really cool. They brought it, they sealed it up, brought it back to Earth, and scientists started studying it, and they found some Streptococcus mitis on the lens, suggesting that this planetary protection concerns that we had signed just 2 years before. In fact, we had signed the Outer Space Treaty months before Surveyor 3 launched. And yet, despite all of the precautions, there was still Streptococcus. And if it had landed on the moon, then the landers that we had sent to other places, such as the Venus and other parts of the moon, might also have had Streptococcus that somehow withstood a launch and a crash landing, well, I guess in this case, a soft landing on the moon. So we had attempted these things, and what that meant was that even though we thought that we were taking planetary protection and forward and backward contamination seriously, we weren't taking it seriously enough. So when we launched something to Mars, the Viking landers in 1975, which we talked about in another lesson, we had many steps involved to try to sterilize every single aspect separately and then all together of the Viking lander capsule as it was put together. So you can see we were taking it a lot more seriously, superheating things to 120 degrees centigrade, just trying to do everything that we could to make sure that no living creature could have withstood these processes. And then we discovered creatures that could live in 121 degrees centigrade. So the planetary protection precautions that we had taken, that we had put in place, it turns out as science developed and discovered more and more, we discovered that there were some creatures that could withstand every assault that we had put our spaceships through. I like these little cuddly water bears, these tardigrades that can go up into space and back on the outside of a spaceship. They can withstand radiation and all of the temperatures on Earth and beyond. They can go for years without food or water. Life is hardy. It's hard to kill, which makes the planetary protection precautions really hard to enforce. So let's go over another reason that space and climate are connected. I'll include a link to the International Space Station. I put that in the link in the previous class discussion, but put another one. You can see live the ISS going around Earth many times a day, many times a day, and just see parts of it. This is not current. Astronauts that have seen Earth from space, whether near or far, report something that's known as the overview effect, this feeling that all of the squabbles that we have here are irrelevant, that who's in charge of one particular bit of dust is not important, that what we should do is care about humans and about our ecosystem and our space. This is a photograph taken Christmas Eve of 1968 in Apollo 8, one of the missions that showed that we could go to the moon before we actually landed there. They were reciting passages from Genesis at the time. This image made it back to Earth, and it was a landmark image, kickstarting some iconography that was used in the environmental movement and is still used. Perhaps the most common image that the environmental movement has used is this the blue marble image, which just shows like you can't see the boundaries between different countries, except for maybe Madagascar and Australia. But you just can't, like the cultural boundaries that we put between us, the differences in language. Astronauts reflected that it seemed to not matter at all once you were out there. And the environmentalists back here on Earth that started pushing for better drinking water, for example. This is a time when rivers were catching fire, when we didn't have a lot of the environmental protections that we put in place after that, and some of which might still be active. We'll talk about those later on in this section. They showed that it didn't matter. The things that we thought mattered didn't as much. This is a pale blue dot. Voyager had crossed, I guess at this point it would have been beyond the asteroid belt, and did. Carl Sagan asked it to turn around and take a picture of Earth right there. And he makes quite a big deal out of it in his books and his work. I'll put a link to it in the video. It's actually very eloquent. Okay, the environmental movement. So these images, these effects, these international things are all happening in the 60s. Another thing that starts happening in the 60s is spurred on by a woman named Rachel Carson, who in 1962 publishes a book called Silent Spring. Silent Spring which the reading talked about, is a book that focuses on DDT, this commercial insecticide that was used by farmers all over the place. The book argues that we eliminated it without quite knowing what we were going to do without it, and then in fact many people have died because we eliminated it. There's some debate on this back and forth between whether Rachel Carson did more harm than good. I think the environmental awakening that a lot of people attribute to people that read Silent Spring might arguably have done more good, even if, you know, it led malaria not to be eradicated and possibly killed millions of, or led to millions of people dying since then. Who knows where we would be if the ecosystem was much more damaged. I don't know, it's a debate to have. The idea behind Silent Spring was that DDT accumulated in insects and the birds would eat the insects and then the birds would die. The book argues that she didn't have good enough science to say that. In the years following, a man named James Lovelock published a book called Gaia, in which he argued that Earth was kind of like its own organism. And so this book made the case that Earth should be treated as its own entity and that it had a homeostatic mechanisms. Again, the scientific debate over this was fascinating, and I'm one of my co-authors, one of my my postdoc supervisor, cut his teeth essentially responding to these claims. But the environmental movement accepted it wholesale and started using it as a metaphor for Earth as an agent that was dealing with a sickness, basically, that is humans. So I'm going to fast forward to the 80s now and tell the story a little bit out of chronology. What was going on at this time, and we didn't quite realize it, was that there was a growing hole in the ozone layer. Ozone is 3 oxygen molecules. By sheer coincidence, it blocks UVB and UVC, some of the most dangerous lights or bit of radiation put out by the sun. UVB and UVC are really bad in that they specifically damage DNA, the phosphate bonds in our DNA. So for most of life's history on Earth, life could not survive on the surface of the planet. It wasn't until a bunch of bacteria called cyanobacteria started pooping out oxygen that oxygen started accumulating into ozone and creating a layer that made the surface of the planet habitable. And over a period of a decade or so, it was getting destroyed, not slowly, but very quickly. You can compare between when we started making these measurements, which it already had, looks like it had been eaten away at, and 1987, which is when the Montreal Protocol was signed, limiting the gas that caused this damage. You can see that there was quite a bit of damage, and it's directly over Australia. One of my new colleagues is from Australia, and in Australia, everybody takes sun care very seriously because skin cancer is very common there because they don't have as much ozone protecting them from the harmful UV light that the sun is putting out. Again, I mean, you live in Reno, and if you don't, if you live somewhere high up, high elevation also is less protection against the sun. So you're more likely to damage your skin, and skin damage, well, it ages you, but secondly, it also makes it more likely that there's going to be the kind of damage that will allow cells to reproduce uncontrollably and kill you, give you skin cancer anyway. We discovered the cause of this was something called a chlorofluorocarbon, or CFC. We agreed in 1987, when that last image was taken, to try to limit these. 2 years later, it was ratified in basically every single country that was a part of the United Nations. The agreement was to gradually limit the use of chlorofluorocarbons and hopefully return to 1980 levels by 2070. So right around the time that you all are retiring. This is during the Reagan administration. Environmentalism wasn't quite as political back then as it is now. Oh, and by the way, we're not going to reach 1980 levels by the time you retire. Actually, we're not even close. The ozone layer seems, or ozone hole seems to be expanding still. So these are videos you can see over time. Yeah, I can click on them. You can see them. No. All right, I'll put the link on the video description. You can see the ozone layer or ozone hole shifting over time. It moves around, it grows, it shrinks depending on the season, but it is much, much, much bigger than it was when we first noticed that there was a hole in the ozone layer. And part of the reason that we noticed it was because of some scientists making measurements using some tools that were used, produced by NASA. NASA had been making measurements for a while, but after certain really high profile failures in the 1980s, including the Challenger explosion, they decided to do what's called a 0-hour review to try to justify every single line of their budget and to give themselves a new mission. If the mission of NASA when it was formed was to get to the moon, Nixon changed it to just shuttle things back and forth to space. And then in the early 90s, they considered maybe we could use the tools of NASA to observe Earth and give us early warning for bad environmental or weather-related phenomena. They also, at this time, started focusing on life. So astrobiology is a field that's created. It's a field that I spent a lot of time in. So, but anyway, mission to planet Earth made lots of observations of the sun, of the clouds, the surface, the oceans, etc. And we use these to observe, for example, the Arctic as it shrank little by little. I'll find the 2020 measurement and show it. It's actually pretty depressing. So we use the tools of space to help us understand climate. And internationally, we came to an agreement to limit this harmful chemical. It's one of the high watermarks of international agreements. We have like the Antarctica Treaty, we have the Outer Space Treaty, we have CFCs. There's a bunch of treaties to end wars, but like these are the big ones that are like motivated by scientific interests. I'm sure there's many more that I'm not mentioning right now. And since that time period, since 1989, CFCs have drastically declined. And we've replaced them with other chemicals. A CFC, by the way, the reason it was invented was to cool items. So refrigerators used to have them. Hairspray used to have them. So hairspray would keep your hair up. Our president was troubled by the early hairsprays that didn't have CFCs, and he has remarked a couple of times that he didn't see how air could leave an enclosed room and get outside. And so spraying hairspray indoors couldn't be a problem. Why did we have to get rid of CFCs, he wonders, or has wondered out loud and publicly. Well, I'm recording this in 2020 before the election, so the current president I'm discussing is Donald J. Trump. Anyway, we replace CFCs with other chemicals. These other chemicals do not destroy ozone. Part of what makes CFCs particularly damaging, they're great at keeping things cool and at giving your hair a nice hold. But part of what makes them really, really damaging is, let me see if I have a picture of it. There we go. It is a 2 fluorines, a carbon, and 2 chlorines. And these chemicals, this particular chemical will interact with an oxygen, with an ozone atom, which is composed of 3 oxygen atoms. And because fluorine is extremely reactive, as is chlorine, and ozone is actually not the preferred state of oxygen. Oxygen prefers to be in the O2 configuration. These CFCs will bond with, will rip apart an ozone molecule, grab one of the oxygens, and then let essentially the other free oxygen will hang around while the rest of the atoms in the CFC try to find other molecules to interact with. So they'll break apart another ozone molecule, and then the stray oxygen from the first ozone molecule that they broke up will actually find itself in a much more favorable configuration with the other free oxygen, and the CFC will reform. So essentially what's happening is that this is just like ripping up a couple of ozone molecules and making them oxygen, O2 molecules, which don't block out UVB and UVC as well. And they can do this for tens of thousands of iterations, just gobbling up again and again different ozones. We had been able to, as a planet, in the billion plus years that oxygen had been pumped into the atmosphere by cyanobacteria and plants and whatnot, we had accumulated quite a bit of ozone, quite a few tons. And in a couple of decades from when they were invented, CFCs were able to destroy so much of it. They were invented by this man, Thomas Minkley Jr., that I mentioned in class. He was an engineer, DuPont, who has many, many patents. He created CFCs to try to cool items in refrigerators. He was also tasked with trying to figure out how to prevent gasoline engines from knocking, that is, making a sound as they were driving. It was very distracting. And he thought to make them heavier, so he added lead to gasolines. We knew lead was a neurotoxin at the time. We'd known it since the Roman times. And he decided that he wanted to market it so that we could put lead in gasoline all over the place. Started his own company, called it tetraethylene, so that people wouldn't realize it was lead. And the baby boomer generation had lead in their gas and in their atmosphere, and also in their lead-lined paint in their homes for decades. Decades until the 80s and 90s when it started getting banned. Lead's a neurotoxin. It is directly associated with decreased development and increased hyperactivity, all sorts of other horrible things. So yeah, Thomas Makeley Jr., one of my least favorite human beings of all time. In fact, the most deadly creature to have existed on Earth ever. Possibly single-handedly responsible for 90+% of all of the cases of ADHD or skin cancer in the world. Not to mention all of the creatures that died because of this. Anyway, I hate this man. Luckily, he dies in his own contraption trying to get out of bed. So let me go back and finish the story of CFCs being banned. They were replaced with other chemicals that did not destroy ozone. They did not. And there was a direct one-to-one trade as CFCs went out of commission. HCFCs and other chemicals like them started being produced. And then we discovered a couple of years ago that the chemicals that we use to replace CFCs were potent greenhouse gases. We're going to go back to this chart at some point, and you'll see that we stepped out of the frying pan and into the fire. We replaced all of these chemicals that had been banned by the Montreal Protocol with other chemicals that it turns out were 10, 100, 1,000, up to 18,000 times worse than a single carbon dioxide molecule. These chemicals were worse than so many other things that we had been producing since the Industrial Revolution, and partially are responsible for the fact that more than half of the greenhouse gases that have been emitted by humans, in fact, well, by humans, have been since 1990. So in 1989, we, as the next lecture we'll get into, in 1989 is when we also started recognizing global warming as a real threat. And we just hit the accelerator by replacing CFCs with these chemicals. But that's a story for another day. Yeah, so fuck Thomas Makeley Jr., and we'll see you in the next video.